In this video, we will explore Python sets. Sets are a fundamental data structure for working with unordered collections of unique elements. They are useful for membership testing, removing duplicates, and performing mathematical operations like union, intersection, and difference. A set is an unordered collection of unique elements, used for membership testing, removing duplicates, and mathematical operations like union, intersection, and difference. Let's look at how to create sets in Python. You can create sets using curly braces like this. Fruits equals open curly brace, apple, banana, orange, close curly brace. Alternatively, you can use the set constructor like this. Numbers equals set open parenthesis, open square bracket, 1, 2, 3, 4, 5, close square bracket, close parenthesis. Keep in mind that to create an empty set, you must use set open parenthesis, close parenthesis, not just empty curly braces. When you create sets, Python automatically removes any duplicate values. Sets can also contain mixed data types, like integers, strings, and tuples, but only immutable elements are allowed. Now let's explore some basic set operations. First, let's create a set called colors. Colors equals open curly brace, red, green, blue, close curly brace. To add an element to the set, use the add method. For example, colors.add open parenthesis, yellow, close parenthesis. To remove an element, use the remove method. Colors.remove open parenthesis, green, close parenthesis. Note that this will raise an error if the element is not found in the set. To avoid this error, you can use the discard method instead. Colors.discard open parenthesis, purple, close parenthesis. The discard method will not raise an error if the element is not found. To find the length of a set, you can use the len function, such as size equals len open parenthesis colors close parenthesis. Here are some common and useful set methods in Python. The clear method removes all elements from the set. For example, my set.clear open parenthesis close parenthesis. The copy method returns a shallow copy of the set. For example, new set equals my set.copy open parenthesis close parenthesis. The pop method removes and returns an arbitrary element from the set. For example, element equals my set.pop open parenthesis close parenthesis. The update method adds elements from another set, or any iterable. For example, my set.update open parenthesis open curly brace 4, 5, 6, close curly brace close parenthesis. The subset method tests if all elements of one set are in another set. For example, a dot is subset open parenthesis, b, close parenthesis, or a less than or equals to b. The superset method tests if a set contains another set. For example, a dot is superset open parenthesis, b, close parenthesis, or a greater than or equals to b. The isDisjoint method returns true if two sets have no elements in common. For example, a dot is disjoint open parenthesis, b, close parenthesis. Lastly, the difference update method removes elements from one set that are found in another set. For example, a dot difference underscore update open parenthesis, b, close parenthesis. Now let's explore some common set operations. Let's start with two sets, a equals open curly brace 1, 2, 3, 4 close curly brace, and b equals open curly brace 3, 4, 5, 6 close curly brace. The union operation combines all elements from both sets. You can perform a union using the pipe symbol like this. Union result equals a pipe b, or by using the union method like this. A dot union open parenthesis, b, close parenthesis. The intersection operation finds the common elements between the two sets. You can perform an intersection using the ampersand symbol. Intersection result equals a ampersand b, or by using the intersection method, like this. A dot intersection open parenthesis, b, close parenthesis. The difference operation finds the elements that are in a, but not in b. You can perform a difference operation using the minus symbol. Difference result equals a minus b, or by using the difference method. A dot difference open parenthesis, b, close parenthesis. Finally, the symmetric difference operation finds elements that are in either A or B, but not in both. You can perform a symmetric difference using the caret symbol, symdiff equals a caret B, or using the symmetric difference method, a dot symmetric underscore difference open parenthesis, B, close parenthesis. Set comprehensions provide a concise way to create sets from iterables using a single line of code. They are similar to list comprehensions, but create a set using curly braces instead of square brackets. Set comprehensions automatically remove duplicates, which is a key property of sets. You can also include conditional filtering using if statements within the comprehension. Set comprehensions are often more readable and faster than creating a set with a loop. Here are a few examples of set comprehensions. To create a set of squares, use this syntax. Squares equals open curly brace, x raised to the power of 2, for x in range open parenthesis, 1, 6, close parenthesis, close curly brace. To add a condition, creating a set of even squares, use this. Even squares equals open curly brace, x raised to the power of 2 for x in range open parenthesis, 1, 11, close parenthesis, if x modulus 2 equals 0, close curly brace. To create a set from a string, you can use this. Unique characters equals open curly brace, C for C in Mississippi, close curly brace. Here are some common use cases for sets in Python. First, sets can be used for removing duplicates from a list. Sets automatically eliminate duplicate values. For example, numbers equals open square bracket 1 2 3 2 1 4 5 3 close square bracket. Unique numbers equals list open parenthesis set open parenthesis numbers close parenthesis close parenthesis. Second, sets are very helpful in membership testing. Sets offer fast lookups to check if an element exists. For example, valid users equals open curly brace, Alice, Bob, Charlie, close curly brace. If user invalid users, print access granted, else, print access denied. Third, sets can be used to find common elements. Use set operations to find shared items between different sets. For example, product 1 tags equals open curly brace electronics gadget phone close curly brace. Product 2 tags equals open curly brace electronics computer office close curly brace. Common tags equals product 1 tags ampersand product 2 tags. Finally, sets are also helpful in data filtering. Filter data using set differences between two sets. For example, list 1 equals open square bracket 1 2 3 4 5 close square bracket. List 2 equals open square bracket 4 5 6 7 close square bracket. Unique to list 1 equals set open parenthesis list 1 close parenthesis minus set open parenthesis list 2 close parenthesis. When working with sets, it's important to consider their performance characteristics. Sets use hash tables internally, which provide very fast lookups, additions, and removals. Membership testing using X and S has a time complexity of big O of 1, meaning it's very fast. Adding an element using isa, add open parenthesis X close parenthesis, also has a time complexity of big O of 1. Similarly, removing an element using s at remove open parenthesis x close parenthesis has a time complexity of big O of 1. However, set operations like intersection, s1 ampersand s2, have a time complexity of big O of the minimum length of s1 and s2, while union, s1 pipe s2, has a time complexity of big O of the length of s1, plus the length of s2. Keep in mind that sets require elements to be hashable, meaning they must be immutable. This means you cannot have lists or dictionaries as elements in a set. Additionally, sets consume more memory than lists for the same number of elements due to the overhead of the hash table. Let's explore frozen sets in Python. A frozen set is an immutable version of a set. Once created, you cannot add, remove, or change its elements. To create a frozen set, you can use the frozen set constructor. For example, regular set equals open curly brace 1 2 3 close curly brace, and frozen equals frozen set open parenthesis open square bracket 1 2 3 close square bracket, close parenthesis. Regular sets are mutable, so you can add or remove elements as needed. However, frozen sets are immutable, so you cannot modify them after creation. Because of their immutability, frozen sets can be used as dictionary keys, unlike regular sets. Some features of frozen sets are that they are immutable, so they cannot be modified after creation. They can be used as dictionary keys or as elements in other sets. They support all non-modifying set operations, like union and intersection. They are created using the frozen set constructor. And lastly, they are useful for fixed collections that shouldn't change. Here are some best practices to keep in mind when working with sets in Python. Use sets when you need to ensure uniqueness of elements. Choose sets over lists when performing frequent membership testing, as sets offer much faster lookups. Use frozen sets when you need an immutable set. Remember that sets can only store hashable or immutable elements. Finally, consider using set operations for various data analysis tasks, as they can provide efficient solutions for common problems. In summary, sets store unique unordered elements. They are efficient for membership testing and removing duplicates. Sets support mathematical set operations, like union and intersection. Only hashable items can be stored in sets, like strings, numbers, and tuples. Finally, frozen sets provide immutable alternatives when you need an unchangeable set. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.